the PPT here. It is text mining and NLP here. These are the areas of where text mining exists, like information extraction, natural language, pres- uh, processing, data mining, and informative analytic. So I'm gonna go with the natural language processing here in my presentation. So introduction to the text mining and NLP. Text mining, the process of deriving meaningful insights from textual data, and the natural language processing is a subfield of AI that enables computers to understand, interpret, and generate human language. This is what natural language processing means. The both are crucial in data mining for analyzing unstructured text data. So here it is, why is it important? Huge volumes of unstructured text data are generated daily. Extracting knowledge from text improves decision making, relation to AI and machine learning. NLP relies on ML for classification, clustering, and prediction. Transformer models, uh, GPT, whatever, significantly improves NLP. Coming to the importance in data mining, like what kind of importance it gives in the in the data mining. Over 80% of data is unstructured, like emails, reviews, social media, etc. Helps to extract patterns, trends, and sentimental sentiments from text. So the mainly it is useful for this and enhances search engines, recommendation systems, and policy making, and facilitates fraud detection, customer feedback analysis, and predictive analysis. I'm going to go with the key techniques in the text mining and NLP. Here it is. The tokenization, it is having tokenization, which is splitting text into words or phrases, and steaming and limmatization, reducing the words to their root form, like removing some of the words which is unnecessary in the data, which we don't need actually. And the POS tagging, it is identify nouns, verbs, etc. And NER, extracting names, places, dates. Sentiment analysis, like determining emotion from text. Topic modeling, identifying themes in large text datasets. Text classification, categorizing text into predefined classes, and word embeddings, like representing words in vector form. And now it's the main part, it's like applications of text mining and NLP. I would go with sentiment and analysis. As we all know, sentiment analysis plays a very vital role in all of this data mining subject. Analyzing customer opinions in reviews. What is sentiment analysis? Like we use this sentiment analysis in very kind of reviewing something. If we go out to a theater, we review the movie, or else we review something about the food is good or not. Like this is a real life, like where we use a sentiment analysis to analyze it's actually okay. So analyzing customer opinions in the reviews, chatbots and virtual assistants, enhancing automated customer and service, spam detection, filtering unwanted emails, and document classification, categorizing new articles, emails, etc. And fraud detection. Fraud detection is one of the very important application where we use in whole data mining, like whatever, wherever, whatever project you take, we definitely find fraud detection in the privacy representing the privacy distraction kind of things. It may be anything, like it may be a kind of privacy representation thing, or uh, representing data presentation, like uh, it actually takes place in like it's fraud detection, privacy preserving data mining using differential privacies, you know, fraud detection in banking system, and also this plays a very thing, it's a role in text mining and NLP also. It helps actually identifying anomalies in financial transactions, medical text analyses, extracting information from clinical notes and health records, And coming to the case study, I mean, like sentiment analysis, I've taken the example, the problem statement, and I've given the algorithm here for this, analyzing customer reviews to determine sentiment. This is an algorithm for that, like data collection, scrap reviews from e-commerce sites, pre-processing, remove stop words, punctuations, and tokenizations, and feature extraction, convert text into numerical format, and model training, train a classifier, maybe base SVM deep learning, and sentiment prediction, classify reviews as positive, neutral, or negative. Example, Amazon help uses sentiment analysis for customer insights. So here, this is an algorithm for it. And now I'm going to explain a numerical example for sentiment analysis, classifying a simple review using sentiment analysis. So review is that example I've taken as the product is amazing. The quality is top notch and delivery was fast. So this is what I've taken as an example. So the first step we do was like tokenization. So what is meme tokenization? We have seen here already. Like splitting text into words or phrases. So we should split that data. Like this is the sentence. So now we have to split the data like into tokens. Like see, da is something, and product is something, and is something, and amazing is something. And also the exclamatory mark is separate, and the da is separate, and the quality is separate, and is separate, top notch, and delivery was fast. Everything with fast with kind of some exclamatory marks on it. And the step two is stop word removal and lemmatization. I told you before, like when I'm reading what is my lemmatization, it was removing the unwanted thing, like clean tokens. By this step one, you have to clear, I mean, you have to clean the tokens, which is not necessary in the upcoming steps. So here, die is unnecessary, is unnecessary, the exclamatory mark is unnecessary, and die here, is here, and was is unnecessary. So take off all that and put remaining into this, like product, amazing quality, top notch, delivery, and fast. Coming to the coming to the step three. Coming to step three, we have to assign sentiment and scores. I mean, as I told you here, like convert text into numerical format. We have to convert that text, so we use that. Okay. Uh, and after that, we have to do model training and production. That's it. You'll get a deployment product, whatever you want, then as an answer, result. So this product is like, yeah, sorry. Yeah, this is assign sentiment and scores. So we need to know what is actually meant by sentiment and scores. Like what is sentiment lexicon? Okay, it's a words like here, like words we have taken amazing, top notch, fast. So yeah, here what is like words like amazing, excellent have positive scores, right? Like it's a amazing. It's been like it's a positive vibe. It's a positive thing. Excellent is a positive, whereas bad is a negative, ignored is a neutral one. So it having positive, negative, and neutral. This three kind of will, I mean, like see here, we'll classify this kind of data and we score them into the sentiment. We assign some scores to them in this particular problem, and we give like a positive, neutral, and negative. So yeah, so these scores are usually derived from linguistic studies or some source data sets like CentiWordNet, AFINN kind of things. And so that is the reason the amazing has it's a strongly positive word. So that's what you have chosen plus two. And you can ask me a question like here, like how you are giving this kind of numbers to only this, like plus two. How you have you assigned this for amazing and plus one for this? You can ask a question. Like, yeah, that's a great question actually. So I want to tell you something like basically why this course they come from pre-established lexicons like AFI and SN scores from -5 to +5. It is very linguistic, I mean, kind of language that we assign to them. in this particular, because it's a you're converting the text into the unstructured data into the original data kind of, it's helping actually. Um, the custom lexicons can be created depending on domain, like movie reviews, product reviews. So these are I mean, like defined, or they are created according to the what the question we have taken. So now we have taken like this, the delivery is fast, so it's a top notch. I mean, some whatever delivery, like it may be a food delivery, or it may be a kind of something, whatever. Like you've ordered something like that. We have given the text like this here. So why amazing? So every word has a sentiment intensity score. These scores are not random. They are based on how strongly a word expresses a sentiment. Okay, sentiment. So amazing. It means you can give +2. Outstanding. You can give +3, like that. Okay, top notch +2. Fast. It's like okay. It's like normal positive thing. Um, And that's not realistic, as some words clearly carry strong emotions than others. So for that, according to the emotion, how much emotion the particular word carries, like that you can give to them. So yeah. So here, like that, amazing +2, top notch +2, fast +1, total sentiment +5. So the sentiment score is greater than 0 is positive, equal to 0 is neutral, and less than 0 is negative. So we have +5. It means positive review. They gave positive review. And so this is what I have given you the numerical example on also the Navy's based text classification that we also use in the text mining. So classifying emails as spam or not spam using Navy base. Okay, the tokenization and the win free tip click versus meeting schedule tomorrow and PM. So you have to do that, and training on the Navy base, like probability of spam is equal to total spam emails by total emails. Not spam, total not spam probability of not spam equal to total not spam emails by total emails. So computing them, like P of word by spam equal to count of word in spam emails by total word in spam emails. Here the word by not spam equal to not spam. P of word of not spam equal to count of word in not spam emails by total words in not spam emails. So here it is. So if you classify them into separately P spam by email and P not spam by email, the probability by using the Navy based theorem, like Navy based thing algorithm, we get the email is classified as spam. This is what, and this is the diagram I have shown, like what it is actually involved in training a classifier in sentimental data collection, pre-processing, algorithm, training model, and test data. Deployment. Lastly, you get the challenges of even like data quality issues. Data quality issues, language variability, context understanding, and computation complexity, and privacy and ethical concerns, bias in AI models. I've given all the information here, like noisy unstructured data, name-based data, multiple languages, realities and slang, difficulty in classifying sarcasm, irony. These are the challenges that they face, and the future research directions is advanced deep learning models transform NLP improvements explained in NLP, multilingual in NLP, real-time text processing, ethical AI in text mining, integration with knowledge graphs. These are all the future research direction. And the conclusion is like text mining and NLP are revolutionary data analysis, provide powerful insights from unstructured text data, advancements in AI with drive further innovation in NLP. Applications are growing in industries like healthcare, finance, and customer strength. Thank you so